How are you today? You're good? Thanks for attending this session. My name is Matteo, and today I'm going to talk a little bit about micro frontends, a little bit about front-end microservices, all of these kind of buzzwords, and a little bit about front-end. So first, let me introduce myself. I work for a company called OpenTable, and I lead a team that is called Developer Experience. So we are a small technical team that sits with other teams and helps these teams to be productive. So we create tools and we maintain infrastructure for improving developers' happiness. This includes developing, deploying code, and maintaining it. I'm a big fan of open source and things like the DevOps movements. I'm originally Italian, but I live in UK. This is how you can find me, so get in touch with me on Twitter, GitHub, Gmail. You can find me everywhere in this one. So let's summarize what we are talking about today. I'm going to talk mostly about these kind of things. So one is the microsite architecture. So when we talk about micro frontends, this is a pattern that I've seen in many places. I'm going to tell you a little bit about the journey of how in my organization we went through this pattern for improving our velocity and solving some of our problems. Number two, I'm going to talk about a framework called OpenComponents that we have been working on and helped us to evolve our micro frontend architecture. And it's something that we open sourced, and I'm going to talk a little bit about that. And last but not least, I'm going to try to conclude with some resources, some tips. We have been trying to play with these ideas and patterns for around 4 years. So we learned a lot of things. We learned about our mistakes, and possibly that could be helpful for a lot of people. But most importantly, today I'm going to tell you a little bit about our journey. What is the reasons that actually made us to pick some kind of patterns? Why we decided to do something like that? So just to give you a little bit of context, I work for a company called OpenTable, as I mentioned, which has been there for almost 20 years now. So as you can imagine, we have a lot of legacy code, a lot of bad code, also a lot of new code. And like every big company, we have a good combination of many pieces of code written in many languages and maintained by different teams that in 20 years alternated various ideas and patterns. The scale, at the moment, we have something around 23 million reservations. The core of our business is helping people to find a table, to book it, and to go dine out in restaurants. Today, my talk is a bit about the website that we maintain, opentable.com, that involves around 50 engineers on the development. And one important thing that is really related to our journey is we are located in many places in the world, but our engineering offices are located in many different time zones. For example, we have a London office, the one where I work for, but we also have our headquarters in San Francisco, and we have an engineering office in Mumbai, India as well, one in Australia as well. So all different time zones, and there are people from all of these offices working together on this website. As you can imagine, it's very difficult to be productive in such an environment, and it took years for us to actually learn how to improve that. Every time we deploy to production our website, and we know that our code is going to be involving millions of people per minute, so that's very important to understanding a little bit the scale. And one thing that we try to do is to really embrace the full stack culture. So despite when I joined the company 4 years ago, we were handling this very big monolithic application. We were transitioning to microservices, and we actually try to encourage people to remove any barrier that makes you auto-define yourself a front-end developer or a back-end developer. And everybody that wants to work on different projects is encouraged and able to switch to different teams to work on different things. This obviously involves also a mindset where you know how you're deploying your code, how you're testing it by yourself. So transitioning from a culture where we have a testing QAs department, release department, having people that deploy code like 2017, I would say. So let's start the story a while ago. As you can imagine, everything starts with a big monolith. And 4 years ago, we had this monolith that was a .NET application, very huge, that has, as you can imagine, very good parts and very bad parts. The good part was consistency. Everything was written in a single language, which was C# for the server, and obviously JavaScript for the client side, but everything was really opinionated. Deploying this application was easy because it was one deployment. On the other hand, the code base was huge. Was very fragile. Everybody was scared about approaching this code base. And also the release cycle was very slow. We had like monthly release cycles. And as you can imagine, for the business, this was not very good. We engineers were continuously firefighting with product because product were perceiving engineers too slow, but we are actually scared about changing anything that maybe wasn't very well tested because we were scared about breaking all the stuff. Just to give you another idea, every time we will do a deployment, we will run something like 6 hours and a half of automation. So a deployment was actually a very painful process, something that we will do very cautiously, and sometimes there will be problems. So the only option will be to just roll back and wait another month. As you can imagine, that was very, very frustrating. So the first thing we did many years ago was to embrace this microservices architecture. On the back end, we started splitting our logic into multiple parts, trying to think about domain-driven design, and that helped us a lot. We actually transitioned to very big teams to actually something like micro teams, 3 to 5 people handling very specific pieces of our business. Teams were able to develop services with autonomously and increase the speed cycle a lot. So one thing that we said was, let's do something crazy. Why don't we apply the same principles to the front end? The front end application is actually an HTTP service. Can we do something like that? And that's what we did. So the first thing we did for actually breaking this monolith on this huge web application was to try to think about something that could make sense. Something that couldn't make us to rewrite the whole thing and take 4 years of the business away from us, but still try to evolve the most critical part to an architecture that could be more robust, maybe a little bit more resilient. So one thing that we did was what we called microsites architecture. I've seen this called in many other ways in the world, micro apps architecture, et cetera, et cetera. The idea being was very simple. Let's break this into multiple parts. We started rewriting originally search, this search experience. So we said, let's create a little web app that contains maybe a couple of pages. So same thing like the search page plus the search result. And the idea was, let's make the search team do that. So the same team that owned the search API and all the complexity related to, for example, maintaining the service, experimenting with search algorithms, ranking, maybe personalization, could be the team that actually could own also this little web app. And as you can imagine, this worked very well. The team was super excited because in a couple of weeks, the team was able to spin up a new web app, and the velocity increased a lot. This team was deploying to production every day, and basically the product manager of this team was the hero of the company. Every team said, oh, we want to do the same. That makes a lot of sense. One interesting thing that came out from this approach was the team was actually able to propagate changes full stack. So they said, if I want to experiment with a new search algorithm, I don't need to create a dependency between a front-end team. We are the same team, so we are able to push changes on the back end, experiment as much as we want, and we can actually propagate these changes to the end user very easily. So this was kind of a first iteration, and it worked until we started creating the second microsite. As you can imagine, we started working on the main areas of our business. So if you think about an e-commerce shop, is almost like the start, is like the home page where you present your products. Search is where you try the user to search a restaurant and to find a good table. And restaurant profile is when you finally see the profile of the restaurant, look at the food pictures, and you say, I totally want to book here for tonight. So different teams have also different kind of domain knowledge and different domain needs. For example, a search team is very expert, possibly, to present the results very quickly to the user, having a very reactive UI, being very quick on the search backend, because we want the search experience to be very, very interesting and plays a very nice experience. But maybe the goals of the home page are actually a little bit different. We want to present to the user a lot of options, maybe experiment with personalization, because we want to engage the user for starting to explore the website. While the restaurant profile is maybe very, very different. The team has the photos of the restaurant, the reviews, so you want to present meaningful content. You want also to involve the user to book, and if that involves a booking, for example, a Michelin star restaurant, that is something that we have, most likely you're going to need to insert your credit card number. So there are security involved, the concerns that possibly the on-page team doesn't need to care about. So this worked, and this is pretty much what happens today. If you with a URL like that, this goes inside our internal infrastructure and goes to a service that we call front door, which is basically some kind of a router that converts this URL to a set of information, some metadata saying this is a microsite called start. We have San Francisco Metro and other additional information. For example, the accept language is here in US, et cetera, et cetera. So we have something like a service discovery. We go to an instance of a start page, passing down some parameters, and that basically renders this page. The same thing we do for other microsites. And as you can imagine, the first problem that we hit when we started working on the second microsite was how to share the common parts. There are many ways to do that, but one thing, and for example, if you are starting to do a microsite, you are working on starting to split something out, you can actually create libraries for sharing your components, so your UI layer, and modularize this in libraries that you can consume, for example, in the JavaScript world that will use NPM. And that could be a perfectly nice approach. Other approaches include using technologies like web components. What we ended up doing was slightly different. The reason was we were so inspired by microservices, and what we noticed was we were locked into .NET for many years, and we wanted to do Node, for example, on the front end. So when people started creating microsite, we said, oh, maybe you can keep using C#, or maybe you can use Node. We started having a lot of diversity on technological choices. Despite this seems scary, at the beginning, that was very important for us, because we were really hungry for innovation. And we wanted to actually have opportunities to actually experiment, possibly fail, but learn a lot. So when you want to implement a library to share a UI element and you have multiple pieces written in many languages, it's obviously expensive, because maybe you want to write a library for a C# application that has its own way to do these kind of things, or one for Node, and that was many years ago. So one other problem you have with libraries is if you're making a change in one place, for example, you want to change a link in the footer, and you have a library that actually includes the footer in multiple microsites, how do you release this? If now one of the goals of microsites is to have independent deployment pipelines so that the team can deploy every time they need, how you propagate this change to production without inconsistencies? And are we actually falling down into a rabbit hole? So the idea is, okay, now we can have multiple independent teams, but every time I need to deploy something, I need to ask many teams to redeploy their things. So it's actually a huge communication overhead. So one idea we had was to create a service for serving these UIs. So for example, what about the header and the footer of the website that here you see with these colors here? And what we did was to create a components API. So one team will own, for example, the header or the footer, which will be deployed as a service that will be able to provide HTML fragments. And that will be what will happen when the user will ask for this URL again. That will go to start page will make an HTTP request to the components API, for example, to ask for an header snippet. That will get the HTML snippet on the server side, for example, and then that will put the various snippets in the page. So the idea will be, well, the search team, the start page team doesn't care about the header and the footer anymore. There is a contract, which is very specific. Each component will have its own API. For example, the header will have a specific contract saying, send me the exact language, so I'm going to serve you the header in English or in Japanese. And one thing that we also started saying was like, wow, yes, there is duplication of front end, but more than likely the UI layer is going to get some data to be rendered. So if we want to use HTML, which is actually a very good way to propagate changes in many languages because it's just a snippet that everybody can put there in any rendering engine. One problem is this HTML is going to be rendered. So what if we actually encapsulate the logic that is needed for something like the header, which has a lot of stuff like user authentication, location picker, search. What if we actually have something like a logic for the header encapsulated all on this endpoint? What we need is basically define a specific API for each of these kind of big components, ask every microsite to make a HTTP request there, respecting the contract, and then with API versioning and HTTP headers, we can actually achieve a good compromise. And as you can imagine, yes, we did that, and it worked for a while. And obviously, it worked, but it started to be problematic because it started to grow a lot. We are talking about 2 years ago now, and we learned that microsites were kind of a good thing. Our microsite for the website were starting to be something like 10, and every microsite was owned by very small teams. Some teams would own 2 or 3 microsites. But this approach was starting to work. One problem is we tried to start advocating this idea. If you have something shared between multiple microsites, possibly we don't want duplication. So let's create a components in the components API. And the result is the components API was starting to grow. We had a lot of components, and it was becoming almost like a monolith itself. And so what we created was something different. We wanted to start tackling some specific problems. So the components, first, they needed to be versioned. So when we wanted to create a new API for the header, because the header API will change, we wanted a way to propagate this change in such a way that wouldn't break all the consumers. So we introduced API versioning inspired by semantic versioning and the way you consume components on a build time. But this time is on runtime. So the idea being, what if we use semantic versioning for versioning the header, and the version 1, for example, has a specific HTTP contract. It requires some mandatory parameters, and everybody can consume the version 1.x.x. So as soon as I need to publish a new version of the header, I can publish version 2, but the version 1 is going to still be available. So we implemented kind of a way that is quite similar to some serverless architectures of actually deploying every version of each component on every change, keeping the full history. So this is how OpenComponents was born, which is the framework that we open sourced and everybody can use, is MIT licensed. So before explaining how OpenComponents works, I'm going to show it to you. So maybe that's going to be more interesting. Let's try. Do you see it right? It's good dimension? Okay. So OpenComponents is written in Node, and you can install it globally. So you are going to have a CLI tool that you can just call just by C that allows you to do a couple of things. The CLI enables you, developer, to create your own component. So in this case, I'm in a folder called components, and I'm going to do a new component that I'm going to call Warsaw. And when I do this, I create a component that has some scaffolding and some opinions. So one of the important things that we learned on these micro frontends is, and microservices in general, I think, is there is this very powerful thing about diversity in terms of tech languages, frameworks, and technologies. But sometimes you need to be careful on not going too far. Because at some point, you're going to end up with 10 teams doing 10 different things. And when someone wants to go join another team, or maybe a team is dismantled, the other team is not going to know how to do that. But another thing you can do, a way to solve this problem is to kind of create a consistency for this department. You can be like a dictator and say to everybody, oh, you can't use this language, you can't do this. But that usually frustrates developers. As I mentioned in the beginning, my team is called Developer Experience. So we try to offer the teams a good developer experience. And in my experience, the best way to try to enforce opinions is to actually make the right thing to do easy to do. So what we did, for example, in this case, is a mechanism to create components that have some specific templates that you can use, so that everybody kind of adheres to specific opinions and formats. But we don't do it in such a way that seems like something that you are going to be constricted into. We just make it easy for you. So there are very good benefits for doing this because you have a lot of stuff done for you. And that's actually good for you. So it's a win-win. Let's see what we can do with this component. I'm going to open an editor now, and I'm going to show you what I did. When I did an initialization, I created a component that is going to look like that. You see it? Yeah. So I have a package JSON. So this creates a folder with my component name, which is Warsaw, yes. And this, for example, has a package JSON that has many information. For example, the component name is on version, which is 1.00. And I can put a description here, which is like, this is a demo component. I can put other parameters here, like the author, the repository, and this component has an API. This component wants a name parameter, which is not mandatory, and it can be a string, and the default is Jane Doe. When I actually go to my template, this is kind of the HTML part of the component. In this case, this uses handlebars underneath, but we have templates, for example, for PAG, or we have a template for using React and JSX. In this case, I'm actually having a piece of HTML that is going to have a photo and hello, and then I have one interesting thing, which is called server.js, which is basically a JavaScript closure that is going to be used to create the view model that is going to be used to render my HTML. So what the server.js can do is many things. For example, you can have a request library and make an HTTP call to APIs. I can make a call to GraphQL, which is something we use, or Falcor. We can actually do possibly very small things, but related to data aggregation and actually compositive model that is useful for my application to actually be rendered. So what I'm going to do now is I want to test this. I want to play a little bit with this. So what I do is ocdev. I watch my folder of component, and I start this in a specific port. Once I do this, I run kind of a web interface that I can open in my browser. And as you can see here, I can go to my component. I can see the API. I can actually see a little preview. And I can actually have a couple of tools that allow me to develop changes. For example, I can go to a preview page that you can see here, and as I did before, you can actually make a request for name equals Matteo, and this is going to generate hello Matteo. One interesting thing that you can do is to make changes obviously in real time. So for example, I want to say I'm very excited about being here, so I want more stuff, and I can see the change propagated here on my web development pipeline. Now, let's stop this. I'm happy with my component, and I want to deploy it to production. So one thing we do, you can add your folder of component to a registry of components. In this case, I created a test registry that I'm going to use for this demo. And with this command, I actually link my folder of components to my registry. If internet works, no, let's retry. Yes, second chance, it happened. So now that I link my component, I'm going to do a cpublish Warsaw. So as a developer, I have the possibility of interfacing with the infrastructure, which is this registry, but I actually am able to independently deploy my component. What has happened now is there is a tool that actually did a lot of operations, such as packaging, deploying, making production ready that little image, and uploaded something to a CDN, and then it gave me a public URL that I can hit to just get my component. So as you can see, now there is something like server-side rendered with something that now is actually a public URL for the image. And I can obviously go, and as you can imagine, maybe this is very small. The URL is this one. Yeah, this will be more readable. But I can actually go to 1.x.x, and I can say also preview, so maybe you can see something. Here we go. And I can also say name equals Matteo. Yay. So what happened here? Let's imagine that I am a microsite and I want to include my component. The contract is pretty simple. I can actually go to my registry now. Let me refresh this page, which has a ridiculous zoom. And the idea is every developer can go to the registry, can look at all the components that can be created. So the idea really is improve the relationship between a component, that maybe a team that maybe creates a component and maintains it, and a team that creates and maintains the web part, the microsite. So here I go to my Warsaw, and I can see that someone published this component. There is like the version, there is the contract. I can learn how it works, and I can see a little preview. Now, let's imagine that I'm the developer. I want to get this. I want to make it, I want to change things a little bit. So I reopen my CLI. I go to my editor, and I say, oh, that was actually a mistake. I don't like it a lot. So let's save this. I go localhost. I look at here. I want to see a preview. That looks good. Now, I decided to change this, and I'm going to publish it. Now, the problem here is this is going to fail, because the registry automatically doesn't allow you to override a component with the same version. So what I'm going to do here is I'm going to go to my package. I think this is a patch, because that was a mistake. So I want 1.0.1 for my component. And now I'm going to retry publishing it. This is going to succeed, hopefully. And the idea really is that the consumer that is consuming my whole component and is respecting the same API contract is actually going to get immediately the new version of the component. And so I'm not going to need to ask all the consumers of the component to redeploy their application. So let's summarize. We have this system that actually improves the experience for a developer that want to create something that is shared between teams. There is something related to the UI part. So we have a template engine. We have templates, so you can actually create your own way to do components. There is a server-side part, which is almost like a Lambda conceptually, but is also self-hosted in the OC registry world. And this basically allows you to publish a component that is the two parts together. So the contract for consuming the component is not anymore a huge, complicated contract for how every UI element could change. It's the contract for give me this component with this name. And the contract between the view model that I'm going to need to render and the presentation part that maybe is on the template can change many times, but I'm not changing the contract from the consumer point of view, which just needs to know how to consume the Warsaw component with the name parameter. As you can imagine, there are many little tools that I'm not going to go through now. For example, I can decide that I want to create a breaking change. I want to create a new parameter that is mandatory, and that's going to be safe because I can publish it as 2.00, and everybody that is consuming 1.x.x is going to have the time to migrate to the new API. So let's go back to the presentation now, and let's go through a couple of concepts that, as you can imagine, are going to come out from this. So a little overview about how OpenComponents works. So we have this system. As you can see, we have a CLI that allows you to create, to develop, and to publish components. This remote is. Number two, we have this registry. So this is the API layer that we can actually use to create, to consume components, to discover components, and to learn about their API. We can actually publish components. So the CLI uses the registry when we publish. As I mentioned, we have these components, which are pieces of static HTML and CSS, but also JavaScript, both on the server and on the client. And then we have templates, which, as I mentioned, it's a kind of a way we use to kind of propagate opinions. Here we saw just a basic HTML template, but as I mentioned, I can have a React template. And then I have clients that allow me to do server-side rendering of my components or client-side rendering. And obviously, so I have a JavaScript browser client, but also a Node client, and we open-sourced a variety of other clients. So this is how it works for a client-side rendering. So we created a couple of kilobytes library, and the idea is you can have a component tag with the registry href. There are a lot of magic that happens here. this kind of library is going to have some caching for anything that is static, and via semantic versioning and immutability, you actually have a lot of advantage in terms of cacheability, as you can imagine. And this is a good choice for components that maybe are not really critical for SEO. For example, you have a component about adverts, or maybe a little like A/B test experiment for a widget recommendation, and this doesn't impact the time to render for the page. This could be a good choice. Then we have server-side rendering. So we actually develop templates in such a way that each component can be completely universal. In this case, this is a client for Node.js that allows you to say, give me the header, and I'm going to have an HTML that when I do the rendering from Express, for example, if I'm using Node, I'm going to take care of putting in the right place. But another thing we have is, as I mentioned, a lot of legacy applications. So if, for example, if you are using C#, which at the moment is a language that is capable of executing server-side JavaScript, but is not super performant in our experience yet, you can actually use the simple API to just get the rendered HTML. And this is going to be a little bit less performant because you have less cacheability, but it works very well. So let's talk about atomic web design. Anyone ever heard about atomic web design by Brett Frost? Someone, yes. This is not really the original image, it's a little bit reworked. But as you can imagine, so for anyone that never heard about it, Brett Frost came with this concept a couple of years ago. I think it's 3 or 4 years ago at least. The idea was to use chemistry to create a parallelism between HTML elements. So you have elements that are possibly not visible, like colors, that maybe constitute your brand as an organization. So you say, this is the kind of red that I want in my website. Atoms are actually things that you can make and correspond to an HTML element, for example, a p tag or a button tag. Molecules are combination and composition of items, and then you have multiple things. So at some point you get to need logic for getting these molecules and make them interesting. For example, you have a search control where you can actually type something with an autocomplete. That maybe is something that already starts to be an organism because the logic comes to place. And then we have systems, which is composition of organisms, for example, an entire web page. So depending on various companies and depending on various technological choices, this division can't completely map the way you are doing things. For example, if you are on the React world, like we are at the moment, possibly you have something like atoms and molecules are treated almost like the same. The way we actually use it internally is we don't use OpenComponents as a replacement for component libraries. So there are still very good advantages of having something like an opinionated system for designing your small molecules and atoms, for example, Angular or Vue.js. So we actually have ways on the low level to design and to distribute these as libraries. We actually distribute our bonds as design tokens, and that's specific libraries. Our atoms and molecules are React components that use the design tokens to actually design their colors, their spacing, their typography characteristics. And then when we arrive to actually compose these things and create data, we actually bundle them inside OpenComponents. So the idea really is we have opinions, but then we have ways to kind of propagate these opinions and in such a way that we have reusability. We don't have repetition for everything we do. So let's summarize. This is today, and after many years of the experimentation, we are still learning. We have hundreds of microservices on the back end written in many languages. We have 23 microsites composing the OpenTable.com. We have something like more than 200 open components because we started using it for things like the header and the footer. We started then creating a tool that will empower people to just use open components for everything. So people use it for widgets. We use it actually for our external widgets. We use it for emails. Anything that actually includes UI components that actually need to go to production in a kind of a continuous delivery fashion. And since actually we started this journey, which was like one deployment every month, we switched to something that, as an average, goes to actually 10 deployments in production, 10 changes, 10 components releases every day in multiple pieces of our website, which is pretty good. So what else? As I mentioned, we use it for emails. So for example, one idea we have now is we have a single tool internally to actually distribute our transactional emails for communication to the user or promotions and stuff like that. And we have actually multiple blocks that are actually released as open components. In the email world, as you know, if you are working with emails, you write this HTML that is a bit ugly with super inline styles, and OpenComponents is good with that because OpenComponents doesn't care about what you actually put inside your markup. It actually just takes care about the delivery aspect. And as you can imagine, we also use it for our external widgets. We have something like more than 40,000 restaurants, and all of these restaurants have a website, and in each website they have our widget. So actually this ends up being a very good mechanism for deploying changes to the widget because we don't need to ask 40,000 restaurants to redeploy. So an interesting thing about also having universal components is you can actually use client-side rendering to debug a production page. Here, for example, there is a little video that shows a Chrome extension that we created for actually going to our restaurant profile. We go to the reviews component, and the Chrome plugin allows you to navigate the previous versions. Here I'm going to the API that is automatically documented. I'm changing the language because I want to see how it looks in Japanese. And I can see a preview client-side rendered. One interesting thing I can do with this plugin is I can say, okay, switch the registry that I'm using for this preview to my local registry. So I can actually go to a production page, I can run my local dev registry to actually do changes, and I can see how they look in production to maybe spot obvious CSS or JavaScript conflicts, or to actually do maybe run automation on top of it and things like that. So as I said, we open sourced it under MIT. Other companies are actually helping us maintaining this little project, and they are using it in production, which is pretty nice. And I want to go on with, before concluding, with a couple of things we learned about micro frontends. So in the last year, I will say, I've heard about many companies that are going through this approach. Very likely big companies that actually need to deal with many teams, very likely distributed in many places in the world, because actually communication is hard. When we actually were working originally, we had to make a pull request from the London office to a repository that was shared by someone in San Francisco, and we had to chase them on the late afternoon when they were just waking up to say, can you review this PR, please? And if they will forget, that would be 24 hours more, and every relation was super slow. So team velocity increased a lot. And I think it's important to notice that our goal wasn't to create team velocity and make this team independent so that they wouldn't need to communicate anymore. The idea is communication needs to happen, but if we have simple HTTP contracts and things like how to generate the documentation and systems that actually implement continuous deployment, the communication overhead reduces. So you can actually make people communicate for the things that matter. So for example, discussing features, but actually stop having communication for things like, can you deploy, deployment happened, yes, no, failed, what happened with this API, etc. As you can imagine, one of the other pros is it's very easy to propagate changes and fixes. We actually happen to be like to have maybe a little incident when we actually had some issue and some conflict on the front end, and having a way to deploy in seconds something everywhere in the website sometimes is something that allows you to maybe limit the damage of an incident just propagating a change, a fix immediately. Flexibility, as I said, we actually experimented with Node.js, which is something we wanted to do today. Those 23 microsite, 21 I think are Node, so we are consolidating on that just naturally because it works very well for us. But this is actually very good for experimentation. So you want in your company to have a good amount of innovation. This means that having tools that allow flexibility to a certain degree are a good thing for you. Another thing we said, just naturally, as I said before, full stack culture started to emerge. People were empowered to actually deploy their application, releasing, testing, and this means that the relationship with product just improved a lot. Product and engineers started to be partners again instead of actually enemies or competitors. And this actually is pretty good for your business. So what are the bad parts? There are many, as you can imagine. So there is a risk of duplication. So templates or cookie cutters or applications that allow you to scaffold projects, microservices, etc., are a good way to avoid that. But to a certain degree, that's going to happen. And you need to be careful culturally to observe the trends and to help teams to actually do the right thing. So be careful that actually you don't start having a situation that is completely out of control. As you can imagine, it's very easy to propagate global bugs as well. So you need to be careful. It's a system that is very powerful, so you need to treat it with a lot of responsibility. For example, this doesn't mean if I actually can deploy something that easy, it doesn't mean that I do a deployment from my local machine. That was just a demo. Of course, you write tests. Of course, you have a CI pipeline. And of course, you care about code quality. So your components create a unit test and are actually stable, and you actually are using this tool responsibly. As I can imagine, flexibility is also a con, so be careful with that. And testing is difficult. So testing is different. When we were actually on the first monolithic application, it was easy to create an acceptance test and let it run for 2 minutes, but then we had a deployment pipeline that was 6 hours and a half. One of the ideas of the microsites was to reduce the domain, to actually draw these domain boundaries a little bit better, and to have applications that are also easier to test, easier to debug, and easy to approach. Testing is difficult because when we have a microsite, it's almost like slicing your big monolith in a vertical part, and then you create something like components to actually bind them again all together horizontally. This means that testing can be challenging. For example, I observed that we switched to actually create a lot of unit testing. Integration is actually really key, and acceptance testing is actually a little bit different. But it is still possible, so it's very important to care about this aspect. So how to get started if you want to investigate and learn a little bit more about the system. So there is this beautiful website that was created and is open sourced and has a lot of resources about this. So I would recommend to have a look at that, and you can learn a little bit about different ideas and approaches. There are many companies, as I mentioned before, and apart from OpenComponents, that are similar frameworks. So one is beautiful open source by Zalando, is called Project Mosaic. It contains various tools. Another companies, for example, Spotify has a similar architecture composed with iframes for their web hubs. So it's similar patterns with a slightly different implementation, but it's very interesting to learn about these kind of things. And I'm going to distribute the slides later, so this link is a little bit ugly. But this is a page that contains a huge list of links, videos about many people talking about this topic. So if you're interested about these patterns, it could be a good way to start. And another thing I will say, just to conclude, start small. As we see with microservices, don't do microservices because it's the coolest thing ever. Maybe you want to start from the monolith. That's a good thing. And if the monolith doesn't work for you, then you try to approach something like that. That is going to change the topology of your architecture, is going to evolve the team structure and the way teams relate dramatically over years. So don't overcomplicate things. Of course, this is really needed because we are a big company with a lot of teams distributed in this way, but maybe you don't need something like that. So, or maybe you can use just a little bit of that. So start small. This is the last slide, I promise. One thing I wanted to say is that I'm a big fan of serverless architectures. I'm a bit sad that every time we talk about serverless in conferences and in events, we associate this word with very famous vendors that are actually trying to innovate in this space, and that they are actually doing a very amazing job. But I think like there is more about that. When we looked at the OpenComponents and the way we actually deploy very easily a piece of JavaScript that composes a view model, we are talking about the same concepts, in my opinion. So serverless as a way to empower teams to actually care about the domain aspects and writing the application logic instead of actually concerning too much about all the infrastructure implication, all about how I'm going to need to scale, how many instances I'm going to need to run for this, are actually a good concept for the front end. So I think we are going to see very beautiful things in the next year or two. So I think there is a huge potential. Another thing is ownership. So we discussed the idea of ownership, but is a double-sided weapon. So let's be careful, because ownership is critical for the DevOps culture. It's important to enable teams to be independent and to take their own decisions. And it's important also to hire very good engineers, because when you hire very good engineers, you need to give them responsibility and trust. When you create trust and you make teams to collaborate, if you have no trust, you have just cooperation, which is completely different. So on the other hand, let's be responsible. So when we have a team that works on their little piece of turf, let's be sure that they still get that they are part of a huge garden that is shared with other teams. So they need to make responsible decisions in terms of the solutions to adopt, sharing, communicate with others, and so be very good citizens of a big company that shares code. And another concept that I would like you maybe to dedicate 5 minutes about when maybe you come back home tonight is this concept that I think I've seen a lot in the web lately. And it's a bit provocative, as you can see, but there is this idea that people discuss since you start working on programming, which is there is one thing that for sure you will never discuss, which is the good code is the code that is optimized for maintainability. This means writing good tests and applying good design patterns and sharing with teams so that you can actually be a good software gardener. Maybe if technologies like serverless open up for different interpretations. For example, what if we think about code to be very small, to be actually optimized for destroyability? And that is not a very new concept. It's very simple and very popular when we design, for example, in the Node.js ecosystem, very small libraries that do something very small and well, so that when you are tired or you want to use something else, you just swap the library with another library. It is very obviously part of the Unix culture, but it's also part of when you write an Erlang program, and you write small programs that you can just recompose and throw away and rewrite. So maybe serverless architectures and front-end are a good candidate for starting to think about good patterns for this reliability. Can I write very good acceptance test and integration test around an important piece of the business so that when I'm tired or when I actually assign this project to another team, the team can use the test and just rewrite the thing on top of it? Just little ideas. And I think that's it. A little thing to mention is this project is here on GitHub. If you find it interesting, please give us a star. And are there any questions that I can answer? Yes. So the question is how client-side rendering works, and when we actually see the interface for actually that custom tag with the href, how much flexibility I have on that. So what I showed there was a kind of just one example that was oversimplified. I actually have many ways. For example, on the client side, that little libraries offers also a client-side API to actually do rendering, multiple renderings with the same request. Things I didn't mention, everything on the OC registries has a layer of HTTP2, so if you want to render multiple components, it's gonna do the right thing for you. And obviously, yes, you can send the parameters for each component, you can actually specify the versions for each component, and you can nest components, of course. So one interesting use case is we have the header server-side rendered because we have SEO-related stuff, but we have little things inside the header that do client-side rendering of other nested components, such as the user notification and stuff like that. So, yes? Yeah, so the question is how I imagine that you handle, you actually interact with the CDN layer, because every time you actually publish a component, of course, you are going to have a lot of little caches on all the clients, and possibly you need to deal with invalidation and other related concerns. So yes, of course. The way OpenComponents works is you can actually spin it up as an API instance, and the requirement is it needs to connect to a kind of adapter. At the moment, we support AWS. It uses basically S3 to actually store all the data and also save all the publicly accessible stuff, but also all the private stuff. For example, the server.js closure, the metadata. So all the API instances use S3 to actually as a data storage, and also a CDN layer. We are actually have a couple of pull requests in place now to actually add more adapters like Google Cloud Platform, and so this is how it works. There are a couple of optimizations that are related to cache invalidation. So we never need to do most likely cache invalidation because of the immutability of component. Each client, when there is a new version of a component, knows that something happened, and when it does, it tries to fetch whatever it needs for the new version of the component, and automatically, when it's going to be ready, every request for the version 1.x.x that at the moment is resolving 1.2.3 is going to start serving 1.2.4. So these caches are usually a 5 seconds caches. So when we have a deployment, all the upload to the CDN, etc., is done from the CLI. So when I actually have the URL, that's already ready to be used. And very likely on that moment, all the clients are starting to update. So on the next 10 to 20 seconds, possibly everybody is going to be able to have the next version. So the idea really was to use immutability to actually take good advantage of caching with this kind of mechanism. Any other questions? Yes. Okay, so the question is, how do you share the sessions between components? So there are many ways. As I mentioned before, OC is not really opinionated about what you put inside the component, but there are actually patterns that you can use, or maybe frameworks that you can use underneath. For example, the way we have multiple components sharing the same state or on the same page, it's via, for example, Redux. If all of these components are React-based and they are actually placed there once rendered, multiple components are going to be able to publish events or to change the global state, and other components are going to be able to subscribe to these events or access the global state. So the idea really is OC doesn't interact with that. It leaves to the people that are creating the components or maybe creating the templates to actually share utilities for doing this. Session, I guess maybe we can talk also about authentication. For example, I may have concerns. I want to access a private system that requires authentication, and I want the registry to actually serve my component only if I'm authenticated. And this is all possible. So the component on the server.js allows this system called plugins. So for example, in our case, we have a plugin that we use for the authentication and all the session management. So the components automatically deal with the authentication, and as a component creator, you can just use simple plugins to actually say this component is protected, this component has these plugins, and access these functionalities. It is quite advanced, so I didn't mention it here today, but you can do a lot of things, and many of the plugins are open sourced as well. Any other questions? No. Thank you.